Grade 9, can you hear me? Hello, grade 9, can you hear me?
Yes, we can hear you.
Yes, hello teacher, good morning.
That's great. Good morning. How are you doing?
Fine, thank you. How about you, teacher?
I'm doing great. Thank you very much. Alright, grade 9, I hope that you are doing well. So today we will continue our topic about the Hellenistic arts and scientists. So before we start speaking, of course, you have already done your project, right? Have you finished your project in grade 9?
Teacher,
Abdurrahman?
is that considered as project or no?
What's considered to be a project?
The presentation.
I believe only you made the presentation last week, right?
Yes.
Okay, you can present it again as a project.
Okay. Thank you.
You are very welcome.
So I present it now?
No, not now.
Okay.
Alright. So today just we need to finish the Hellenistic arts and about the arts and the scholars, etc. So that we cover all the topic. I believe it's not gonna take much, only for 15 minutes or something. We will just finish this page and then we can just start our presentations for the project. So once again, we have spoken about the Hellenistic arts and science. So we started by saying that the cities that Alexander the Great has already constructed, they were much larger. And by much larger, we mean because of the place or the area. Bear with me, please. Point here for the maps, for example. So if you can see here, guys, okay, that's the old Greece, okay, and still nowadays with the same name. Here is Greece, and that place here, Romania nowadays, and Serbia, and also Bulgaria. Some of them were in the Macedonian kingdom, okay, Macedonia, where Alexander was born, and his father Philip II started to invade the city-states of Thebes, Athens, and also Sparta. Thebes in that place, that's Athens, and here was Sparta. After Alexander started to live here, if you can see, the area here is limited, so limited, okay, compared with the place that Alexander started to march towards and start to take. So one of the cities he started to construct was Alexandria in Egypt. And if you can see, Egypt, it has plenty of area right here. So it's very huge compared to Italy, compared to Greece, compared to Macedonia, compared to the other city-states and the early Greek civilization. So you will discover now that here in those cities that he constructed, it had much open area, okay? It's very huge. But compared to Athens, for example, or Sparta, they are still limited because of the geographical feature. We said that most of the city-states of Athens was just made because of the city-states were limited because of the geographical feature. Okay. All right, so he came here from Macedonia. Most of Greece, we said approximately 80% of it was mountain, and still up to this day. 80% of the land is mountains. So it was so hard for Alexander to build very strong and big cities. Consequently, once he started to construct and make other cities like Alexandria, he had much area, much place to make a city in it. So those cities were just vast, very, very big. So the cities in the Hellenistic world employed armies of architects and also artists, because now they have both the needed materials and also they have the land. Consequently, they can just construct and make temples, you name it, temples, palaces, and of course other public buildings were much larger and grander than building in the Greece. So if I ask you why, so if we said here, why? So why were the temples, palaces, and other public buildings much larger and grander than the building of classical Greece? Simply because of the geographical feature. Here in the place of Greece, most of it, 80% of it, are mountains. So these are mountains, all of this is mountains. Only very, very, very few places where you can construct a city. And even if you are constructing a city, it will be by the mountains. A city by the mountains, the mountains, the mountains. On the other hand, once we go to the cities that were constructed in the Hellenistic period, you will find out that, like Alexandria, there is no mountains. It's a flat land. See how much of the city is? All of this, and all of this, there is not a single mountain. So, because simply the geographical feature of the new places where the Hellenistic periods or Hellenistic cities were constructed, so they had much area for making huge temples, magnificent palaces, and other public buildings. Okay, got the idea?
Yes.
Okay. New philosophies, of course, emerged in those places, because you must put in your mind that each place has its own geographical, cultural, philosopher, or every sort of ideas. All of them are different from one place to another one. Okay, so far so good. So
Yes.
philosophy is totally dependent upon the place itself. It's totally dependent upon the place itself. So if we come back again here, for the Greek people, like the city of Athens, they regarded philosophy as wisdom and to love for wisdom, and they started to construct their whole governmental uh, process and the ideas of their government upon philosophy. Okay, from democracy, and they started to evolve. In Sparta, for example, Sparta was here in this exact place. So for Spartan people, they thought of philosophy as some sort of monarchy, because we said that the Spartans were ruled by a warrior king, okay, like Leonidas in the 300 war between Persia and him. For the Macedonian people, they also believed their philosophy is a type of monarchy, because they were only dependent upon one king, which was Philip II. So, for the philosophy, we will now compare the philosophy in the Greek period to that of the Hellenistic one. So, political term, of course, we have covered that yesterday, but we're just revising. Okay, So, political turmoil during the Hellenistic age contributed to the rise of new schools of philosophy. The most influential was Stoicism, okay, and it was founded by Zeno. That's very important. Urged people to avoid desires and also disappointments by accepting calmly whatever life brought. And for this school, we can compare it to which school? One of the schools that we have studied last semester. The idea of that school, just to accept what life gives you and just to live in harmony with nature. Like which school?
There were two schools, right?
Yes.
One start with TH and one with M. But I forget the
Sarfada
name.
and Mahayana, bravo.
Yes.
Nice, very good, Abdurrahman. Nice way to remember them. TH and M. Nice. Okay, so they are like the Confucianism, okay, whether they are Theravada or the Mahayana, okay, just to live in harmony with nature and just to accept whatever lives may give you. Today we'll speak about one of the most important mathematicians in the Hellenistic period. So let's speak about math and astronomy. So once again, I asked you that question at the first of the last semester, if you can still remember. Why would any civilization take a great interest in astronomy? In the old age, of course. There is one main reason for any civilization to take great interest in astronomy. The ancient Egyptians took great interest in the astronomy. The Mesopotamian civilization, the Indian civilization, the Chinese civilization, the Greek civilization, the American civilization, the Persian civilization. All of the other civilizations of the ancient world took great interest in astronomy, although they were not capable of going out of our atmosphere, not like ours today. So why did they take, or why did they, or why were they very interested in astronomy? One major reason is what? Come on, Salman Swalam, hello, Hidari, Ahmad, Abdurrahman. Shall I make Mr. Abdu answer for you? Come on. Yes, Ahmad. Where is your mic, guys? Open your mics. Why would any civilization take great interest and great care of astronomy?
Maybe to know the time or something.
Time. No, it's not about the time. Okay. Type in the chat. Just one word. Astronomy means
Planets.
planets, space, right?
Yes.
And whom do they think is living in the space?
Their God.
That's it. So most of the civilization took great interest in astronomy back then in the history, 2 or 3 or 5 or even 7,000 years ago, because most of them were polytheists and most of them believed that their gods are living in the sky. Consequently, they needed to be connected to the divine power. And how can they be connected to that divine power? Just by studying astronomy. We can counter the ancient Egyptian. They studied planets and movements of the sun and the place of our planet regarding to the sun very accurately in order to create the temples, in order to make the tombs, like the Great Pyramid. We have already studied it, and we said that it's in a total perfect alliance with the North Pole. So they studied all of these arts and science in order to come closer to their divine powers. Okay, and we will come counter that also in the Hellenistic period, how they applied mathematics and astronomy in both their daily life and to be connected to the divine power of their gods, as they were polytheists. So, Abdurrahman, can you read, please?
Yes. Math and astronomy advanced. During the Hellenistic age, scholars built on earlier Greek, Babylonian, and Egyptian knowledge. In mathematics, Pythagoras, who had studied in Egypt and Babylon, derived a formula to calculate the relationship between the sides of a right triangle. His interest, what?
All right. So, we need just to highlight this or underline this. So, in the Hellenistic age, the scholars, the scientists, they developed or they built their early knowledge upon Greek, Babylonian, and Egyptian knowledge. So, scholars built their knowledge upon that of the Greek, Babylonian, and the Egyptian knowledge. And of course, this is still to be practiced nowadays. If, for example, one of you is becoming a scientist, of course, you will not start from scratch, yet you will see what other scientists have reached, and then you will continue from their work, right? If I'm studying right now about the atom, so I will not start how to find the atom. They have already found the atom. They have defined the atom. They have told us about the atom and everything about the reactions and the atom and all of this. So I'll just take their research and start continuing after. That's the way science works. Okay, so the scholars in the Hellenistic period did the same thing, which is taking the knowledge from the early Greek, Babylonian, and Egyptian civilization and started to develop on them. Pythagoras, for example, okay, or what we call him in English, Pythagoras, or Pythagoras in Arabic, okay, he adapted one method that's still used today, which is the way to measure the length of triangles. So we have this formula or this equation: a square plus b square equals c squared on a right angle, okay, or triangle. And the right triangle, I believe you have studied that in grade 6, grade 5, something like that. A square plus b square equals c square, right?
Yes.
So, for example, if I
Yes,
have
ma'am.
here a equals, yes, in mathematics, Pythagoras, he was mathematician. So if a, for example, equals 3 and b equals 4, then I can calculate 5, which is c, which is 5. Okay, guys?
Okay.
Teacher,
Yes?
when we do a present project.
We'll just finish this page today and we'll continue with our project, okay?
Okay, okay.
Okay, so once again, Pythagoras or Pythagoras, he has created a formula in order to just calculate the relationship between the sides of a right triangle. So he's a very, very well-known mathematician, and still up till our day today, we are still studying his same formula. So his interest is in the principle of mathematics and also the relation between numbers and ideas of a proof influenced Plato, Aristotle, and later Western thought. So simply, he adapted what other scholars and other philosophers from the early Greek and Egyptian civilization have already reached, and then he started to continue upon their work. Abdurrahman, continue.
Uh,
Lead.
Euclid wrote The Elements, a textbook that brilliantly compiled earlier works and became the basis for modern geometry. From stated axioms or assumptions, Euclid built a logical and rigorous geometry. The Elements had a powerful impact on Islamic mathematics, and Latin translations of Arabic versions first made it known in Europe. Since it was first printed in 1482, more than 1,000 editions have been published.
Another philosopher and scientist in that era of the Hellenistic period was Euclid. In Arabic, we call him Euclides in Arabic. So Euclid, he was so interested in geometry. He presented for us some of the theories and some of the hypotheses. Still, up till this day, also practiced like that of Pythagoras. So both of them contributed very much in the knowledge that we still have today. And of course, he affected so much in the Islamic mathematics also because he lived at that period, 1482. It was the period when Islam has already came, and most of the Muslim scholars started to contribute to the science in a very efficient way. Also, we'll speak about using mathematics and careful observation. The astronomer, okay, we have another one here. Aristocrates, he argued that Aristocrates is an astronomer. Okay, so Pythagoras was interested in mathematics, algebra, and also geometry. Euclides, he wrote the book of the elements. Okay, these are important, guys. Okay, and we have Aristocrates. He was an astronomer who argued that the Earth rotated on its axis, orbited the Sun. What we have proven to be true nowadays using our modern technology. So at that time, some people in the church in Rome, they thought that the Earth was flat. And I don't want to tell you that, but some people still today think that the Earth is flat. Okay, but Aristocrates, he proved to them that and argued that no, the Earth is a sphere and it has an imaginary axis and it rotates on that axis. By the way, the Earth is tilted to its axis by 23.5 degrees. That's what causes for us to have day and night. We have the different seasons, etc. And he told them that the Earth moves first around its axis and then also moves around the Sun. So rotates on its axis and orbits the Sun. Orbit the Sun means in a specific orbit. Orbit like a place where it's strictly guaranteed. So no one can change 1 millimeter from that orbit. Okay.
Okay.
So this one is good. So here the imaginary red one. Can you see it? The red line. That's even better.
Yes.
Okay, this red line is the axis, and that white one is the equator. Okay, so the Earth is tilted to its axis by an angle of 23.5 degrees. Here, just to get you the idea. So that here is the axis, and let's just imagine that this one, this line, that's the equator. And this one is the axis. The angle here, this angle equals 23.5 degree. And if you can see here, because of this, oh, it's already written here. And if you can see, because of this angle, guys, okay, we would have here the day in the northern hemisphere is not as the day at the southern hemisphere or at the night. And because Earth moves around both its axis, number one, rotates its axis, and orbits the sun. And by the way, the orbit is oval, not spherical. Okay, it's an oval one, like this one. Okay, orbit is oval one. So of course, because all of this, we have Aristocles. He just argued with the scholars back then and that time that Earth, yeah, this one, that's the best one. Okay, so an oval orbit around the sun. This orbit is never ever to be changed. Okay, and by the way, it's not stable. It's not in 2D, but it's in 3D. So the sun itself moves around itself and also the galaxy, and the Earth is moving around itself and the sun and orbiting in the galaxy. Do you understand? So we have the sun moves, it's not stable. Okay, it has been already proven that the sun moves, and it's mentioned in the Quran, in the Holy Quran. And the sun runs to its rest. Okay, so the sun moves, the earth moves, and all of them until our God just started the doomsday. Okay, so we have one of the scholars back then, whose name was Aristocles. He just mentioned those facts back then. Of course, he was fought by some of the Roman scholars, yet he proved his theories, and nowadays, using our modern technology, we can prove him right. And the theory of heliocentric or sun-centered. So heliocentric means sun-centered, or the solar system, was not accepted by most scientists until 2000 years later. His ideas, of course, about Earth's motion inspired the Polish astronomer Copernicus in the early 15th. Aristocles also used geometry to calculate the size and also the distance of the sun and the moon. So imagine, I just need you to imagine, like 2 millennia ago, 2 millennia guys ago, those people started studying everything about our astronomy. That today, with our modern technology, we cannot be accurate as they were. So how fascinating, really, those people were. So Aristocles also used geometry in order to calculate the size and distance of the sun and the moon. Another Hellenistic astronomers, Eratosthenes. Eratosthenes, very important one. Eratosthenes, he showed that Earth was round, not flat. Earth was round and accurately calculated its circumference. So Aristophanes proved that Earth was round, not flat, as most of the scientists and the Roman Empire thought. Even, by the way, anyone during the Roman Empire, if he thought or said that the earth was round, not flat, they will just hang him, kill him. Okay, so Aristophanes during the Hellenistic period proved that earth was round, and it was proven. And accurately, of course, calculated its circumference. On the measurement, that's the name of his book. Okay? On the measurement of Earth, that's the name of Aristophanes' book. On the measurement of the Earth, it was lost, but other ancient authors preserved some details of his calculation, his theory, his formula, still up till this day, a little bit received. So far, so good.
Yes.
Any questions so far? If you have any question, you don't understand anything, just tell me, type in the chat, anything. Okay. The most famous Hellenistic scientist, of course, Archimedes, okay, as we call him in Arabic, or Archimedes. Archimedes, or of sources, he applied principle of physics to make, hold on a moment. So Archimedes, he applied principle of physics to make particular inventions. So he was an inventor. Okay, he mastered the use of lever and the pulley and postard. Okay, the postard was an instrument that enabled them from seeing outer planets or objects in the sky. Give me a lever and long length and a place to stand on, and I will move the world. That was his code or his proverb. Then, to demonstrate the power of his invention, Archimedes used it to draw a ship over the land before the crowd of awed spectators. In 212 BC, at the request of the king of Syracuse, Archimedes devised machines of war to defend his own hometown against the Roman attack. He also invented the Archimedes screw, a mechanical pump still used in many parts of the world to lift up water to higher level of irrigation. That's it. So simply by moving the wheel, okay, so this tube will make the water come from a very low ground into a higher one. Any question about those scholars?
No, teacher, thank you.
Pythagoras, okay, Aristophanes, Archimedes, and I believe you have already studied some of them in other topics like mathematics.
Yes.
Okay, so medical practice improved. How would the medical practice improve? Put this in your mind. By the development and flourishing of any civilization, medicine must be developed. Come again?
By tools, teacher. I have better tools.
Better tool, probably, and better understanding of the human body itself, and better understanding of the causes of illnesses. The plague, for example. Once the plague happened, it killed approximately a quarter of the humans back then. But today, plague still existed, yet there is a vaccine for it because we understood it. Diabetes, for example, people were just killed. They were put into a room and then they are gonna die. There is no solution. But once they discover the insulin, so they can live, and people live with it nowadays. Okay, so simply once we become developed, we come to a common understanding of the circumstances of the illness and also our human body. How does it work? Consequently, we will be able to face such diseases. Imagine, just imagine, if coronavirus, okay, spread 2 millennia ago. If such a disease spread 2 millennia ago, like coronavirus, it will just conduct in most of the world will have be killed, like what happened with the plague. But because we become developed, we come to a common understanding and a common awareness. Okay, we become aware of the threat of that disease. Okay, back then at the plague, stupid one, I don't know what to call him, but stupid. Okay, he made a rumor that when someone carrying a plague hugs a healthy person, so the plague will leave his body and be transferred to the other person. And of course, this act helped in spreading this disease and led to the death of approximately a quarter of the people living in the world back then. Okay, but now because we have such awareness of the diseases and such awareness of how our bodies and the viruses work, so our medicine is getting improved. So medicine practice improved, of course, about 400 BC. The Greek physician, his name was Hippocrates. He studied the causes of illnesses and looked for cures. So first he started to study the human body and what would cause an illness to occur, and then let's cure it and find some medicine. So the Hippocratic oath, okay, attribute to him set ethnical standards for doctor, and doctors still up this day use his oath like to make a commitment. Okay, I swear, like when you go to court, you say, I swear to say the truth and nothing but the truth. Doctors still use his oath nowadays, which is, I swear that I'll help everyone and every patient and never to do something harmful for them, etc., to the end of their oath. So, Greek physicians swore to help the sick according to my ability and judgment, by never with a view to injury and wrong. So his oath, his commitment, okay, was still used till this day, of course, but was some sort of oral and ethnic thing to provide help for those who need. Doctor today still make a similar one. And a remarkable legacy, of course, of the last point about this topic. So with its concept of Asia Minor in 133, Rome replaced Greece as the dominant new power in the Mediterranean world. Okay. However, the Greek legacy remained. Greek workers or Greek works in the arts, science, and also every aspect has set a standard for late people of Europe. Greek ideas also about law, freedom, justice, and government contributed to influence political thinking to the present day. Even the idea of the Council of Elders or the Council of 500 in Athens still nowadays practiced in our own societies. Socrates, Plato, Aristotle, and other many Greek philosophers developed an idea of critical thought and also self-examination that allowed people to question ideas and also institutions. Citizens could participate and judge government. Later, the founders of Western political system, including the United States, studied these ancient Greek ideas as part of their classical education. The Athenian experiment in direct democracy by citizens' participation thus had a deep and far-reaching impact on modern politics and government. Of course, all of these achievements and their impact were especially remarkable because they were produced by a scattering of tiny city-states whose rivalries left them too weak to defend themselves from conquest. Later, you will learn, of course, about the Greek legacy influenced by the Roman and blah, blah, blah. So, simply we can counter that the achievements of those people, of the Athenian people, of the scholars, the artists, the artisans, sculptors, the great people who lived at that period, still nowadays being studied so that we can learn from them. So we study them to learn from their wisdom, from their philosophy, and so on. Any questions so far?
No, thank you.
No, thank you.
All right, you are very welcome. So now we have already finished topic 5. If you have any questions about topic 5 from the start of the early Greece civilization until Alexander the Great and the philosophers, anything that you wish, have no hesitation to contact me directly.
I have a question, teacher.
Yes?
Can you add optional worksheets for the quiz so it can assist?
I'll do my best, Abdullah. I have no
Okay.
worries about that.
Thank you, teacher.
All right. Any other question?
No.
All right. Get ready. Starting from tomorrow, you will present your final project for the third quarter. Nice to meet you again, grade 9, and see you tomorrow.
Thank you.
You are very welcome. Bye.
Bye.